Hello everybody, welcome to topic number 11, polynomials and polynomial functions. Today we're going to take you through some very basic definitions of polynomials. As well, we're going to show you how to go through and work with adding and subtracting polynomials. First off, let's start off with what is a polynomial. Polynomial is an algebraic expression that can be made up of a lot of different things. It can be made up of variables like x or y. It can have coefficients, which are just numbers in front of the variables. And it could have exponents that are whole numbers. So for example, if I gave you the following, if I gave you 4x cubed minus 3x squared plus 6x minus 12, this would be an example of a polynomial. We have variables, which are in this case would be x. The coefficients are these numbers in front, 4, negative 3, 6, and negative 12. And if you notice, all of our exponents are whole numbers here. And again, remember, if I have a variable that doesn't have an exponent, we can pretend like that is a 1. What are not exponents? So very important. There's some things that could look like exponents that are not. So for example, if we have variables in the denominator, we have something like 1 over x. Or something like 2 over x squared plus 3. These are not polynomials. More so if we have negative or fractional exponents. So if I give you x to the negative 4th power, or I say something like x to the 1/2 power, these are also not polynomials. We learn later on that x to the negative 4th makes that variable go down to the denominator, which we cannot have. And we learn also later on that 1/2 ends up being some sort of root or radical that we use. So these are things that are not classified as polynomials. A term is just a single number of variable or a product of both. So when we go through, kind of the best way we talk about it, let's make a polynomial. I've got 4x to the 4th minus 3x squared plus 9x minus 12. So if I'm looking at this polynomial here, a term is literally anything separated by a plus or a minus sign. So in this polynomial here, I have got 4 different terms. And again, kind of the best way to remember it is it's separated by either a plus sign or a minus sign. Terms can be made up of just numbers, they can be just variables, or they can be a combination of both, as you see here. The coefficients are the numbers that are in front. So in the polynomial above, 4, negative 3, 9, and negative 12, those are all the coefficients of my polynomial. A constant, it's just simply a number that doesn't have a variable. So for example, let's say I gave you the polynomial 5x squared minus 12x plus 3. This 3 right here is the constant. It doesn't have any variables attached to it. And the degree of the exponent is the highest exponent in a polynomial. So one of the things about polynomials is we always typically like to write them in what's called descending order. And descending order is simply we put the highest exponent first. So typically, the degree of the exponent of the polynomial is typically the one that's in front. So if I make up this polynomial and I go 6x to the 4th minus 3x to the 3rd plus 10x squared plus 9x minus 8. Again, in this case, the 4 would be the degree. So this would be a degree for polynomial. It is the highest term, it is the highest exponent in the polynomial. So when we look for degree, we look for the highest exponent. We make sure our polynomial is written in descending order. If it's not, we just move exponents and coefficients around to put it in descending order. How do we find the degree of a polynomial that has multiple variables? If we have a polynomial with multiple variables, all we're going to do is add the variables and the exponents together to find the degree. So for example, if I have 3a to the 3rd b squared Well, all I would do is take 3 plus 2, and I would find that this would be 5th degree. So again, we'll add all the exponents and find it out. Let's write out a polynomial. We have 5a to the 5th, b squared, minus 6a, b to the 3rd, plus 12, a to the 3rd, b, minus 8, a squared, b to the 4th. So to find the degree of this polynomial, we've got to look at all the exponents and figure out which one's the highest. If I add these two, 5 and 2 make 7. If I add these two, remembering that if there's no exponent here, it's really a 1. So 1 and 3 would make this 4. This would be 3 and 1, also 4. 2 and 4 would be 6. So this one would be the highest. This would be a 7th degree polynomial. For those with multiple variables, we're not as concerned about writing them in descending order. As you can see here, technically if we were writing in descending order, the negative 8a squared b to the 4th should be the second term. But we're not as worried about that when we're talking about multiple variables. Now let's classify some special types of polynomials. If I give you a term monomial, I'm simply talking about a one-term polynomial. So for example, 3x to the 4th would be a monomial, or something like negative 8x would be a monomial, and even a constant. If I gave you negative 2, those would all be monomials. A binomial is a two-term polynomial. So if I gave you something like 5x squared plus 3, this would be a binomial. I can't combine the 5x squared and the 3, and there's two different terms written here with it, so this would be a binomial. Again, I could do 4x minus 6. This would be a binomial. I could go through and do 3x to the 3rd minus 3x to the squared. Again, these would be binomials. We can't combine them together, so we've got two separate terms, and they're separated by one sign that's either positive or negative. A trinomial is something that has three unique terms that cannot be combined. So for example, 5x squared plus 6x minus 3. None of these can be combined because they all have different variables or no variables at all. So this would be a trinomial. Same thing if I did 10x to the 4th minus 8x squared minus x. None of these can combine, so this would be a trinomial that has three terms. And anything above three terms, we just simply call it a polynomial with however many terms it has. So for example, if I look at 5x to the 6th minus 8x to the 4th plus 3x cubed minus 2x squared plus 5x minus 6, I would count here and I'd see I have 1, 2, 3, 4, 5, 6 terms. So this would just simply be a polynomial with 6 terms. We really don't have any names for anything that goes above 3 terms. Adding polynomials. Adding polynomials is no different from when we went through and did combining like terms. We're simply looking for what they have in common and following the signs in front of them to make sure we combine them correctly. So in this polynomial addition problem here, we're going to look and see what we combine, starting with the highest exponent. Here I've got a 2x squared. It can combine with this 3x squared. 2x squared plus 3x squared gives me 5x squared. Remember, when we combine like terms, we combine the coefficients, but the exponents don't change. Next, I've got a positive 3x and a negative 5x. Make sure if there's a minus sign, we count it as a negative when we go to combine it. 3 minus 5 gives me negative 2x. Then we have the constants. 2 minus 1. 2 minus 1 gives me a positive 1. Nothing here to combine. I've got an x squared, an x, and a constant. So this will end up being my final answer. When we go through and combine add polynomials, we're simply combining like terms. Here again is two more examples. Let's start with the top one here. Notice a couple of different things. It's not written in descending order, so we're really going to have to look for what is the highest exponent, and some of the exponents are missing. We'll see what happens when we get to that point. So looking at this top problem, the highest exponent I see is 5y to the fourth. So this is a fourth power. We'll look to see if we have any more fourth powers, which we do here. So we'll combine 5y to the fourth and 3y to the fourth, and we'll make 8y to the fourth. Now typically next we would go to the third powers, but we don't have any third powers. So we'll skip it. We don't need to write 0y to the 3. We're just going to pretend like it's there. It's not there. We can't do anything with it. Next, let's go to squareds. Here I've got a 4y squared. Well, no other terms have a 4y squared, so all we're going to do is bring that down because it does not combine with anything. Next, let's look at the ones with an exponent of 1. Here I've got an 8y, and I've got a negative 13y. Remembering that we're really going to subtract 13 when we do it. So I've got 8 minus 13, which gives me negative 5y. Finally, we'll go with the constants. I've got negative 12 plus 5. Negative 12 plus 5 gives me negative 7. Again, I know I'm all complete when I can't combine any like terms at the end. I can't combine anything that has a 4, 2, 1, or a constant with each other, so that is my final answer. We'll do the same thing at the bottom. Again, we've got some multiple letters here, so we've got to make sure we combine things that are correct. Doesn't really matter the order here, so let's start with the front. We've got a 5x squared, and we've also got a negative 7x squared. So those can combine here. 5x squared minus 7x squared gives me negative 2x squared. Next, I'll take a look. I've got a positive 7xy, so I need something else that has xy with it, and that's what I have here. So I will combine those two. 7 minus 4 will give me a positive 3xy. Now be careful on the next one. Here I've got negative 3xy squared, but the last term I have over here is x squared y. These are not like terms. One of them has an x and a y squared, the other one has an x squared and a y. They're not going to be able to combine. Since there's nothing else to combine them with, we will bring them down just as they are. So again, when we look to combine like terms with things that have multiple variables, their variables and their exponents have to be in the exact same. Subtracting polynomials is basically the same idea, except there's going to be a negative sign in front of the second polynomial. We're going to simply distribute the negative sign into it. So we're going to have a negative and a polynomial like this. And all we're going to do is distribute the negative sign, remembering that if there's no number really written there, it's like we're distributing a negative 1 into the second polynomial. And anytime you multiply by 1, it just keeps everything the same. So when you multiply by negative 1, it's really just going to go through and flip all of the signs. All the coefficients and the variables will stay the same. We'll just go through. The positive 3x squared became a negative, the positive 4x became a negative, and the negative 3 became a positive. Once we do that, we go back to like what we were doing with adding like terms. We'll just combine everything that has like terms to get our correct answer. Let's try it here. So we're not going to do anything with the first polynomial. That could stay the same. The negative 5x cubed minus 2x squared plus 7 will not be touched. We're only going to distribute the negative into all the terms that are in the second polynomial. Again, remembering this is really a negative 1. So we're going to take all of these and flip their signs. A positive 4x cubed will give me a negative 4x cubed. A positive 7x squared will give me a negative 7x squared. A negative 3x will give me a positive 3x. And a positive 2 will give me a negative 2. Now let's look to combine. I've got a negative 5x cubed and a negative 4x cubed. Those will combine because they both have x cubed. Negative 5 minus 4 is negative 9x cubed. Next, I've got an x squared, so negative 2x squared and negative 7x squared will combine. Negative 2 minus 7 gives me negative 9x squared. Over here, I've got a 3x. I don't have anything else that has an x, so that 3x will come down as part of our answer. Finally, we'll take a look at our constants. I've got a 7 minus a 2. 7 minus 2 gives me a positive 5. Again, nothing to combine here left, so this is my final answer. So really, we're just adding polynomials. We just have that one step at the beginning where we have to take that negative value and combine and distribute it into the second polynomial. Let's do the same with this problem. Again, we're going to take this as a negative 1. We're going to distribute it right into the second polynomial. The first polynomial is unchanged. We're just simply bringing it down to be able to combine it with the opposite of the second polynomial. Positive 4x squared becomes negative 4x squared. Positive x becomes negative x. And then positive 4 becomes negative 4. Now I have a 3x squared y here. I've got nothing else that has x squared and y. So we'll bring that down as part of our answer. I've got 6x squared minus 4x squared. So 6 minus 4 gives me 2x squared. Here, I've got x minus x. Well, x minus x becomes 0. It just cancels out. So we'll cross it out, and we don't need to put it in our answer. When two things cancel out, just leave it out of the answer completely. The only thing left we have after that is the negative 4. There's no other constants, so we'll bring that down as part of our answer. So again, some common mistakes to avoid. Forgetting to change the signs when subtracting. Make sure if you're subtracting, your answer could come out negative. Understand that. Make sure you combine don't combine unlike terms. Make sure what you're combining is actually like terms. The variables have to be exactly the same. Take note, if you have 3xy and you have 5yx, are these like terms? Yes, these are like terms. You can write the variables in any order, but they have to have the same amount. So in this case, they both have one x and one y. These would be like terms. And making sure you drop, when you go through, you're dropping your negative signs. That's typically a common reason why people miss problems. You have to make sure you watch those negative signs when you distribute them, and then when you go through and combine them. If you remember all this, you will be successful when it comes to polynomial operations.